Hello everyone, welcome to lesson 6-2, reflections. We will continue to address the question, how can you best show or describe the change in position of a figure? So essentially the figure on a coordinate plane. And we're going to look at define these words, reflection and line of reflection. Some of the math symbol we will use will be the following for coordinates. Okay, so often replacing or modifying one of the coordinates so that we can create a reflection across the y-axis and across the x-axis. Real world link, art. Pisanki is the ancient Ukrainian art of egg decorating. Many artists use flips and line symmetry to create their designs. Use the activity to create your own Pisanki design. So you can see here that we have an oval shape which go across all four quadrants. The template shown represents the front view of an egg. The template has been divided into four sections, right, or four quadrants. Step 1, to create your egg, draw a design in quadrant 2. So here we go. So we have quadrant 2, we draw a design, okay, almost covering a quarter or so of the quadrant. To complete quadrant 1, draw the mirror image over the y-axis. So we're going over the y-axis. So if we're going to move in this direction, we have to change our x coordinates. We have to make them all the opposite because we're going from here all the way across to the x. But our y remains the same because we're still moving up in the positive direction. Okay? Step 3. Repeat steps 2 and 3 to fill quadrants 3 and 4. You can create a new design or you can draw the mirror image over the x-axis. So if I was going to mirror quadrant 2, I need to go down, right? I need to go down to make it here. So going down is a vertical change, which means a change in the y coordinate. But I'm still on this side, right? I'm still on the negative side. So I would not change my x, just simply. So if I need to go over the y, I change, if I need to go over the x-axis, I need to change my y. If I'm going to go over the y-axis, I need to change my x. So let's see what I just said in a more detailed or simpler explanation. So reflections in the coordinate plane. Here's what we mean by it. In words, we mean to reflect a figure over the x-axis, multiply the y coordinates by -1. Okay, this is the technical way of doing it, or you can just simply change it to the negative. But you get the point. So it would go like this. We're trying to go over the x, right? So we have to move vertically, up or down, to go over that axis. So that means if we're moving up or down, we need to change the y. And they're telling us to multiply our y coordinate times -1, so it makes it into a negative. And we move in the opposite direction, vertically. And you can see it down right here. There's a reflection, okay? To reflect a figure over the y-axis, so now we're going over the y, left to right, we have to change the x-axis. So multiply the x-coordinate by -1, so that it becomes, because if it was negative already, it would become negative times negative, would still become positive. If it was positive, positive times negative becomes negative, right? A reflection is a mirror image of the original figure. It is the result of a transformation of a figure over a line called a line of reflection. So your x or your y-axis. In a reflection, each point of the pre-image and its image are the same distance from the line of reflection. Makes sense. From the mirror, essentially. So in a reflection, the image is congruent, the same, to the pre-image. Example 1. Triangle ABC has vertices A, 5, 2, let's see here, 5, 1, 2, 3, 4, 5, and 2, there it is, A, B, 1 and 3. B, we go 1 and 3. 1, 2, 3. And C, negative 1, 1. C, negative 1, 1. There it is. Okay? Graph the figure and its reflected image over the x-axis. So we have to go over the x, which means we're making a vertical change. Then find the coordinates of the vertices of the reflected image. So what we want to do is because we want to go over the x, we have to change the y to the opposite. So you see here how we went 1 for B, right? For B, 1, 1, 2, 3 positive. What if we still went 1 but 3 negative? 1, 2, 3. You see? That would be a reflection. Here we went negative 1, positive 1. We still go negative 1, but now we go negative 1 as well. Okay? So we're changing the y coordinate to the opposite. All right. And you can see here that the new coordinates, I'm just going to circle it for you guys. For A, it was 5, 2. Now it's 5, negative 2. For B, it was 1, 3. Now we have 1 and negative 3. And for C is negative 1 and 1, negative 1, negative 1. So you notice here that each y changed to the opposite value that we have here. What's the opposite of 2? Negative 2. Opposite of 3? Negative 3. And opposite of 1? Negative 1. Now we're going to make a reflection of this quadrilateral across the y-axis. So if we're going across the y-axis, we have to make a movement horizontally. So we have to change the x to the opposite. Example, for K, I move 1, 2, 1, 2, 3. So it's 2 and 3. And there it is, K, 2, 3. But now I want to go to the other side because I want to make a reflection across the y-axis. I need to move horizontally in the other direction, so I have to change my x. So again, instead of going to the right 1, 2, now I have to go to the opposite direction 1, 2. But I still keep my positive 3y. My positive y coordinate, which is 3. 1, 2, 3. You see that? Okay. So going across the x-axis, the y-axis, we have to change the x. Going across the x-axis, we have to change the y. And you can see that here. Again, look. We change the x, the 2 to negative 2, the 5 to negative 5, the 4 to negative 4, and the 1 to negative 1. Make sense? Okay, if you think you got it, let's try this question here together. Make sure that you pause the video if you think you can do it on your own. Okay? Triangle PQR has vertices P 1, 5, Q 3, 7, and R 4, negative 1. Graph the figure and its reflection over the y-axis. So if I'm going over the y-axis, the reflection, I have to change my x. Right? Because I'm going to move over the y, so that means I have to move horizontally to the other side. Okay? Then find coordinates of the reflected image. Okay, I can tell you right away what my coordinates are. Since I'm going over the y, I know I have to change my x. So I am going to take all of the x's from each point and find their opposite. Okay, so my P1, my image, will be negative 1, 5. That's the opposite, right? And then my Q1, my Q from my first, my image, will be the opposite of 3 is negative 3. And I get 7. And R, okay, the opposite of 4 is negative 4. And negative 1. And there's my new sets of coordinates. So what would this look like if I were to graph it? It would look like this. Here I have my pre-image and my image. So as we mentioned, we went across the y, so we had to change our x. For example, the coordinates for P from the pre-image was 1 and 1, 2, 3, 4, 5. I want to make a reflection, like you're looking into a mirror, on the other side of the Y. So the only one I have to change is my X because I'm moving horizontally, okay, across the Y. So instead of doing positive 1, I'm going to do negative 1, but I'll still keep my 5. 1, 2, 3, 4, 5. As you can see here, negative 1, 5. When it was originally 5, 1, 5. Okay? I hope this is making sense. Okay, look at this figure here. We have, I guess, half a frog, okay, with coordinates A and B, right? And here we have the other side of the frog. So we drew one side of the frog and then we made a perfect reflection so that it would be completely symmetrical, and we would have a reflection on this side in order to complete the drawing of a frog, right? Essentially, we're telling a computer program to reflect this picture perfectly on the other side, so we have to enter these coordinates. So the figure below is reflected over the y-axis, right? There's the y-axis and it's reflected over it. So we're moving horizontally. Find the coordinates of point A and to the 1 and point B to 1. Then sketch the figure and its image on the coordinate plane. So point A is located at 1, 4. Point B is located at 2, 1. Since the figure is being reflected over the y-axis, multiply the x-coordinates by negative 1. Now this is how they tell us to do it. Multiply it by negative 1. When you multiply the coordinate by negative 1, you're simply going to get the opposite coordinate. So you can just go ahead and change the first one to their opposites. Opposite of 1 is negative 1. Opposite of 2 is negative 2. So my new coordinates will look, as you can see here, there's my 1, right? It will become negative 1. Oh, sorry. It will become negative 1. My 2 will become negative 2. So you see? Or as they say, if you multiply it by negative 1, you're simply just changing the symbol over to negative. Because a positive multiplied times a negative is negative. Or negative times negative will be positive. And this would work. In short, what we want to say is the x-coordinates are opposites and the y-coordinates are the same. So if you're going across the y-coordinate, the y, you keep the y's the same. The only ones you have to change are the x's. If you're going over the x, you keep the x the same and you change the y's. Okay, if you think you understand reflections, here's another example. Remember to pause and try it on your own to see if you're able to do it, and then watch the rest of the video to make sure you did it correctly. So the figure at the right is reflected over the x-axis. We only drew one half of the sun, and now if we reflect it properly, it should be able to create a perfect mirror image across the x. Remember, if we're going to go across the x, we keep the x the same, but we change the y. So the figure at the right is reflected over the x. Find the coordinates of point A1 and point B1, then sketch the image on the coordinate plane. Okay, I'm not sure if I can sketch this as it is, but I can definitely tell you what our coordinates are. I'll first start with A. And when we look at A, we have 1, 2, 1, 2. So we go negative 2, positive 2, right? So I go I write negative 2, 2. Okay, and for B, I have 1, 2 in the positive direction and 1, 2 again in the positive direction. Okay, so simply 2, 2. I did say that when you're going across the x, keep the x the same because you're still moving horizontally the same way. The only thing changing is instead of going up, now you're going down. So that means the y has to change. So this is my y. And if I follow the suggestion the book gives to multiply by negative 1, it'll still work. So I do negative 2, and then for the next one, 2 times negative 1 is negative 2. Okay, so that point would be right there. And then for my B1, my image now, I still keep my 2 because I'm still moving horizontally the same way, but now I'm changing my vertical to negative 2. So again, I would move the same way, and the other point would be right about there. And this is what it should look like when you draw the reflection. Okay, I did not draw this. I simply took a picture of the textbook and embedded it. Here's our short guided practice, questions 1 and 2. Take a look through it, make sure you understand what they're asking you to do, and if you're not clear, go back to the examples on the video. And if you're still not clear then, please bring your questions to class. See you then, everyone.